Okay, the time it's 5:05. Very good afternoon to everybody. So welcome to this simulation workshop. My name is Dr. Tan Chin Hon. I'm the Deputy Head of Outreach and External Relations at the Department of Industrial Systems Engineering and Management at NUS. And so today I'm very happy that we are able to have this chance to illustrate to you what you can actually potentially do with simulation. And at the same time, we do have a very small Excel example that we will run through at the second half of this workshop, just to illustrate to you how you can actually use simulation to answer some interesting questions over there. Okay, and so without further ado, let's get into today's workshop. So I hope to keep this interactive. And so basically, if you have any questions along the way, feel free to just type them into the chat box. And then as and when they pop up, I will just address them at the appropriate time. Okay, and so any questions that you have, feel free to just go ahead to type them into the chat box. And so now let me just quickly illustrate, just like all the other workshops that we've done, I like to illustrate a simple project that our students have done before for the industry to illustrate to you what can be done with simulation. So this group of students, essentially, they were attached to a manufacturing plant. And so the manufacturing facility, it's going to be relatively big over there. And so they were in particular, they were looking at this process where there was a testing station. And so essentially what happens is that when the jobs are going to be processed at the testing station, essentially we need to perform a certain series of checks to make sure that this batch of job is okay before we can proceed it to the next stage of the production over there. So what is going to happen is that once the testing is done, then the operator is going to call for the next batch of jobs. And so how the next batch of jobs is going to come is that essentially there's going to be an automated material handling system. So you can think of this sort of like an automated library. Okay, so just imagine at some corner of this manufacturing plant, there is going to be an automated library over there. And so essentially when we call for the job, this library is going to essentially pull out that next set of job. And once the job has been pulled out, it will request for a AGV, an automated guided vehicle, to come along to actually pick up the job and to bring this job to that testing station over there. Okay, and so from here, I hope you can realize that if we wait until we finish this job before we call for the next job, then basically my operator and my machine over here is going to be idling for a very long time, especially if there is going to be a jam. For example, if by the time you call for a job, there is no AGV that is around. And so we got to wait until a AGV is available before we are able to bring this job to my operator over here. And so what is going to happen is that it's going to make sense for us to actually call for a job before we're even done with this job over there. Okay, so you want to call for it in advance. The challenge over here is that you do not want to call for it too early in advance as well, right? Because if you were to call for it too early in advance, what is going to happen over here is that then the job is going to come, but this job is not completed. And so what has to happen is that this job and this AGV will actually have to sit here to wait until this operator finishes this job before this operator can work on this second job. And then this AGV can take that completed job back to our automated material handling system over here. Okay, and so, and besides the AGV just waiting for this operator to complete, there are also other complications with having too many jobs around this testing machine area as well. Okay, and so a fine balance has to be achieved in terms of whether the jobs arrive too early or they arrive too late over there. And so when our students were tasked with this problem, essentially what they did was, no surprise over here, right? This is a simulation workshop. So how they tackled this problem was essentially to build a simulation of the factory floor. So this was not the simulation that they built, but this is just an illustration of what a simulation would potentially look like. But essentially then what is going to happen over there is that then they would be able to simulate different types of rules over here. So should we be calling for the jobs 15 minutes before we complete our current job, 20 minutes, 25 minutes, 30 minutes, and so on. And so using the simulation, they will then be able to test the performance of each of these dispatch rule, as we call them over there. Okay, and so not surprisingly, if you were to call it only 15 minutes before you complete your job, then it's going to perform well in terms of some of your KPIs over here, but it will perform poorly in other KPIs. So the KPIs, the key performance indices, some of the things are like machine idle time. Okay, and so basically if you call for it, the earlier you call for it, then your machine is going to have less idle time over there. The later you wait to call for it, the higher the chance of your machines being idle. Okay, but this is only one part of the equation, right? This is the one that controls basically the machine aspect of it, whether if your machine is idling or not. But there's also the other aspect that if it arrives too early, then essentially there are going to be the other complications that your AGV may be tied up, or essentially that you would have too many jobs idling around this testing machine as well. Okay, and so that is going to be the third KPI over here. The idle lots are arriving earlier than the expected time over there. Okay, and so essentially through a simulation, you would be able to test out the different strategies and see which one is going to be the best for the company. Okay, and so I hope with this, we've given you a very quick illustration as to how simulation can be used in practice to help our businesses look at their operational decisions and look at how to improve the way that they do things. Okay, so once again, I hope to keep this interactive. Along the way, if there are any questions, feel free to just go ahead and type them into the chat box over there. I'll be happy to answer any questions if you have. Okay, but so far it looks like there's no questions. So let's move ahead. Okay, and so basically, when we want to make changes in practice, it can actually be costly. So back to our previous example over there. So perhaps the management might be thinking that, oh, okay, we might not have enough AGVs, and so we need to purchase more of these AGVs over there. Okay, but purchasing AGVs, purchasing any type of equipment, for example, let's say you want to come up with your automated material handling system. Those are going to be very expensive investments over there. Okay, and so besides the purchasing of equipment, you could also be thinking about hiring manpower. So perhaps we don't have enough manpower. So imagine you are running a hospital, and then we are asking the question sort of like, okay, how much reduction in the waiting time we are going to be able to achieve if we hire one more doctor or if we hire one more nurse over there. Okay, and so you could make these changes, but it is going to be costly. Okay, and the other aspect about implementing changes in practice is that it's not only sort of like identifying what is the right approach over there to hire manpower or to purchase equipment, but at the same time, you are also going to require the buy-in of the stakeholders. Okay, and so the stakeholders can be people like the managers who would give the approval for the purchasing of this equipment or the hiring of the manpower, or it could also be the operators who, in the end, are going to be the people who are using this equipment over there. Okay, and so you are going to require their buy-in. And so if you say that we want to actually automate our whole process, you will need to also convince the operator that this is going to be better for the company in the long run, just like how you will need to convince the managers as well. Okay, and so simulation is going to be very helpful in terms of these, because rather than you just purchasing the equipment or hiring the manpower and then see what happens over there, you could actually first do a simulation to try to estimate what is going to be the impact of these changes of these purchases before you actually go ahead to purchase it. And at the same time as well, through simulation, you would be able to demonstrate to the managers, the operators, what is going to be the impact of these changes over there. Okay, and so you can demonstrate to them the benefit that it brings before you actually ask the operators to do this change, or before you ask the management for approval for the purchase of these equipment or the hire of the manpower over there. Okay, and so so not surprisingly, simulations are going to be very valued by companies out there. Okay, and so that is essentially just a quick run through about simulation. Hopefully, I've given you some practical context as to why this is going to be a useful tool. And if there are no questions, or if there are, we can always leave it to the Q&A later. What I want to do is that I want to launch into today's problem that we will use simulation subsequently to talk about it further. Okay, and so this is going to be the problem that we're going to be looking at today. So just imagine somebody, a soccer player, who is going to be taking a penalty kick. Okay, and so we're going to refer to this person as the kicker. And we're going to consider a very simple problem over here where essentially this kicker will decide to kick either to the left or to the right of the goal. And of course, if you're familiar with the game of soccer, then there is going to be a goalkeeper who is guarding the goal. And the goalkeeper is then going to have to decide to either dive left or dive right over there. Okay, and so we're going to make some assumptions over here. So the first one over here is that basically, if the goalkeeper dives in the wrong direction, then a goal is going to be scored over them. Okay, and so if the kicker decides to kick left and the goalkeeper dives right, then essentially we score a goal. Similarly, if the kicker kicks right and the goalkeeper dives left, then we are going to score a goal. Okay, in essence, the assumption over here is that all the shots by the kicker is always going to be on target over here. Okay, the next assumption we're going to have is that the goalkeeper will always make a save if the goalkeeper dives in the correct direction. And so if the kicker kicks to the left and the goalkeeper dives to the left, then essentially the goalkeeper would save the ball. And so there will be no goal over there. Okay, similarly, if the kicker kicks to the right and the goalkeeper dives to the right, then basically the goalkeeper will save the ball. And so there is no goal over there as well. And the next point to note over here is that the goalkeeper is going to be very good at predicting the kicker's intention over there. Okay, and so the kicker recognizing this, the kicker decides that, okay, I'm just going to flip a coin to decide whether to kick left or to kick right. Simply because if the kicker was to just, go with his own intentions, whether to kick left or to kick right, the goalkeeper is going to be very good at predicting the kicker's intention. So rather than to make the decision by himself or herself, the kicker has decided that he or she would just flip the coin to decide whether to kick left or to kick right. And the kicker is also going to be very good at identifying patterns as well. And so it's going to be able to identify the patterns that the goalkeeper is going to demonstrate, whether if he or she is going to dive left or dive right with a certain type of frequency pattern and so on over there. Okay, and so the goalkeeper recognizing this is going to also decide whether to dive left or to dive right by essentially flipping a coin over here. Okay, and so at this point in time, just a quick side note over here. So I am not sure if you're aware of this or not, but humans in general are very bad at displaying random behavior. And so if you want to be truly random over there, you do not want to actually come up with the random procedure or the random decision by yourself, but very often it is better to just relegate it to some inanimate object. For example, a coin over there. Okay, and so if you were to flip a coin over there, because the coin doesn't have the psychology that humans tend to display over there, it is going to be very hard to guess the intention of the coin. And so that's why the outcome of the coin will then be considered random compared to, let's say, the the patterns that are displayed by individuals over there. So very quickly, if you are interested, there is going to be this article that was written about it. Let me just put it onto the chat over here. You can feel free to just check it out during your own free time over there. So essentially, there was this experiment that was done by a professor. This was done quite a while back. So essentially what he did was he gave a homework assignment to his students over there. He asked the students to essentially flip a fair coin 200 times, and then to write down the sequence of the heads or tails on a piece of paper as a homework assignment, and then to bring it to class the next lecture over there. Okay, and then he said that you can do this assignment physically, or alternatively, you could just try to, come up with the random procedure yourself, which means that rather than flipping the coin 200 times, you just think in your head whether this coin flip is a heads or tails, a heads or a tails over there. Okay, and so this was the assignment that was given to the students. Okay, and so why did the professor give this assignment to the students? Because during the next lecture, when essentially the students came with this assignment over there, the professor then basically just quickly run through the solutions of each of the students. And essentially based on the submission over there, the professor was able to correctly identify who were the ones who actually physically flipped the coin 200 times, and who were the ones who actually faked the results by just manually simulating the random numbers or the random outcomes over there. Okay, the conclusion from that is that essentially that humans in general are just very bad at coming up with random behavior. And so if you really want to disguise your intentions, then in a situation like that, flipping a coin is probably going to be the best way, especially if your opponent is going to be very good at identifying the patterns that you demonstrate over there. Okay, and so you can check out the article if you are interested. It talks about Benford's law, which is going to be related to that as well, that very often you're going to identify certain types of patterns around. Okay, and so with that, I hope at least I've given the context in terms of the problem that we are looking at today. Do we have any questions regarding this very simple problem? Essentially, you have a penalty kicker who decides to kick to the left or to the right, and you have a goalkeeper that decides whether to dive to the left or to the right over there. Okay, and essentially all shots are going to be on target, and if the goalkeeper dives in the correct direction, he or she is going to be able to make that save over there. Okay, and so under this situation, there are a few questions that we can potentially ask over here. The first question that I would like you to think about is essentially, suppose that the kicker kicks right 50% of the time and is going to kick left 50% of the time. That means there's a 50-50 chance the kicker will either kick left or right. And if the goalkeeper is going to do the same as well, is going to dive left and right 50% of the time each as well. What is going to be the probability of, let's say, a kick resulting in a goal? So that's the first question to think about. The second question to think about is, what happens if the goalkeeper decides to dive to the right 40% of the time and dive to the left 60% of the time? What then is going to be the probability of a goal being scored over there? Okay, and the last question that I would like you to think about over here is that, suppose that if our kicker over here, it's very good at kicking to the right, but it's not as good at kicking to the left over there, such that if he or she kicks to the right, there is 100% chance that the shot is always on target. So then it depends on essentially whether if the goalkeeper correctly guessed the direction, that's all. Okay, but if our kicker kicks to the left, then there is only a 50% chance of that shot being on target, which means that there's a 50% chance that we will still not score a goal, even if the goalkeeper was to dive in the wrong direction over there. Okay, and so for this particular question, we want to ask So under this situation, how often should the kicker kick to the right? 50% of the time, 40% of the time, 60% of the time, or what? Okay, and so that is going to be essentially that third question that we are interested in. And of course, what is going to happen is that the results are going to depend on how the goalkeeper actually decides as well, right? But this is where, following from our assumption over here, so understand that the goalkeeper is going to be very good at understanding what the kicker is going to do. And so the goalkeeper is just going to adjust accordingly over there. Okay, and so with that, let me just quickly bring up this poll over here and launch this poll. And so I hope that the three questions over here are clear. If not, feel free to just raise your questions in the chat box over there. And so I have opened up this poll with these three questions. Probably let's just take about 3 minutes to think about it and then to just give you a response over here. Okay, so don't worry about giving a wrong response. So just think about it and just answer it based on your intuition over there. Okay, so based on this problem that I've set for you, you want to ask yourself, what do you think is going to be the probability of scoring under the first two situations? And under the third situation, if you were the kicker, how often are you going to kick to the right and how often are you going to kick to the left over there? Okay, so for the true answer, don't worry about, obviously you can solve this by analyzing the probabilities and so on, but you don't have to worry about it at this point in time. Later on, we will do a simulation to look further into this problem over there. Okay, anyway, it is a simulation workshop, right? And so the idea over here is just to let you think about, what do you think is going to be the solution? And later on, once we have the simulation, we can come back again and revisit our initial intuition. Okay, great. So I think we already have about 25% of the people giving a response. So for the rest, no problem. We'll give you about another 1 more minute. So take your time. Okay, so we have about 65% of our participants who have answered. So for those who have not, if you wish to, quickly just go ahead and register in your thoughts over there. Let me just give you another about 10 more seconds. Okay, and then let me just go ahead and end the poll over there. No problem. This is just to get a sense of what everyone is thinking over there. And let me just go ahead and share these results. Okay, so thanks to everyone who has shared over there. So like I say, no problem. This is just to get a sense of what our general intuition is going to be regarding this problem. And later on, we can make use of this to investigate our simulation over there. So very quickly, let us first run through this first question over here. What is the probability of scoring if the kicker kicks does right and left 50% of the time each, and the goalkeeper does right and left 50% of the time each? You have to look at it. Most people are guessing that it's going to be about, the probability of scoring is going to be about 50% over there. Okay, so let me just quickly just write this down over here first, so later on we can come back to look at this. Okay, but let's get on to the second question. Okay, and so if we look at the second question over here, I believe you are able to see the simulation result. I mean, you're able to see the poll results as well. For the second question, it seems like we have about 24%, or about 1/4 of you thinks that it's going to be about 50%. Another one quarter of you thinks that it's about 50 to 60%. Another one quarter thinks it's going to be about 60 to 70%. And there is another 16% which thinks that it's going to be about 20 to 30% over there. Okay, so it's not as overwhelming as the first question over there. Okay, but so for the second question, we're thinking it's either about 50%, 60%, or some are saying 20% over there. Okay, good. Let's go to the third question over here. Okay, and so suppose that our left shots are only going to be 50% on target. Under this situation, how should we be kicking our ball, knowing that the goalkeeper is going to adjust accordingly? And under this case, what we have over here, it seems like the overwhelming, it's going to be about 70%, 70 to 80%. We have about one quarter of our audience saying that. At the same time, we have another 20%, 22%, and another 16% saying about 50% or 60% over there. Okay, and so let me just make a quick note about this. And so later on, what we're going to do in the next stage, essentially, we're going to quickly just build this simulation, and then we can come back to explore these questions over there. Okay, so thanks again for registering your thoughts. So let me just stop share, and then later on, we can come back to this. Okay, and so essentially, now we're going to be making our decisions just based on the flipping of a coin. And so essentially, we want to just make use of Microsoft Excel to help us flip the coin over there. Okay, once again, it's important to note, I'm not using the flipping of a coin for decision making just because it makes life easy. But as mentioned just now, that if you truly want to be random over there, you do not want to leave it to humans to actually generate out that random decision. Okay, humans are going to be very bad at generating random decisions. And so if you're in a situation over here against an opponent who is going to be very good at identifying patterns, you actually want to simulate the flipping of a coin to come up with a truly random decision. Okay, and so what I want to do next is that essentially I do have the Excel. We're going to use Excel to build this simulation. And so I've already created a template. And so I'm going to share it with everybody via this chat over there. So let me just close this. And so I'm sharing this. So let me just share this with everybody. Okay, and so hopefully you would be able to receive this Excel file over here. And so later on, we're just going to make use of this Excel template over there to just run through the simulation. And at the same time, we are recording this session as well. So I think we have, it's not too complicated. You should be able to follow along. But in the event, if you're not, don't worry. We always have this recording that we will share with you subsequently that you can review through the materials again. Okay, but let me just quickly highlight a few points over here. So in Microsoft Excel, what is going to happen is that there's going to be this random function that allows us to generate a random number between 0 and 1 over there. And so if we want to simulate the tossing of a fair coin, essentially we can just generate out this random number and look at what the number is. If the number is less than 0.5, we can say, let's say that it's heads. And if it is more than or equals to 0.5, it's going to be tails. Or in the context of our problem, if it's less than 0.5, we say the kicker kicks to the right. And if it's greater than or equals to 0.5, then the kicker is going to kick to the left over there. So in such a way, we are essentially going to be able to simulate the decisions of our players over there. Okay, the decisions of the goalkeeper can be simulated in a similar fashion as well. And essentially, if you have a buyer's coin, if you want to, let's say that there's only a 40% chance of getting heads rather than tails over there, all you need to do is just adjust this number over there. Okay, rather than 0.5, it can be 0.4, 0.3, and so on. And so with that, then you would be able to simulate those buyer's coins. Okay, and with that, the next thing that I want to do is that basically we want to open up that Excel spreadsheet that I have just sent to you. And then we would be able to just use that to create our simple simulation over here. So give me a minute while I open up the file on my laptop. So meanwhile, if there are any questions or if along the walkthrough of the simulation, if there are any questions, feel free to just type them into the chat box and then I'll be happy to address them. And so now let me just share my spreadsheet over here. And so right now you should be looking at my Excel spreadsheet. And so for my Excel spreadsheet over here, and so this is where we are going to essentially be doing our simulation. And so over here in cell C1 over here, I'm just going to be putting in the probability that the kicker is going to kick to the right. And basically 1 minus this number is going to be the probability that the kicker is going to kick to the left over there. And so to tackle our first problem, we say that the kicker is going to kick right and left with a 50% chance. So let's just go ahead and put 0.5 in over here for this for the kicker. And at the same time, for the goalkeeper or the goalie, it's going to dive right with 50% chance and dive left with 50% chance. So let's just go ahead and put a 0.5 over there as well. Okay, the next thing that we want to do is that essentially we want to generate out a random number. And so for the random number, essentially we are going to be using the function RAND over there. Okay, and so just go ahead and type this over here, equals RAND, and then open and close bracket. And basically it's just going to generate out a random number over here. So let me just copy and paste this onto the chat box so that in case you need to, you can just go ahead and copy that and paste it over here. Okay, and you can go ahead and press F9. Essentially what happens over here is every time you press F9, it is going to generate out a new random number. Observe over here that this random number is going to be between 0 and 1. And so with this, we will then be able to simulate the decisions that our keeper is going to be making over there. So what I'm going to do over here, I'm going to use the if function. So in your Excel cell over here, you just go ahead and press equals, and then you press if. And so I'm asking if this number over here, is it less than this number over here? Okay, recall this was how we make a decision, right? If this random number is less than, let's say, 0.5 over here, then basically I'm going to say that the kicker is going to kick right. So let me just put this double quotes and then a R. Okay, this is basically to just tell Excel that I want you to display out the letter R over there. Alternatively, if that is false, so this is where you can see over here. So if it doesn't pass the logical test, if it is false, then I want to print out the letter L over here. Okay, and so let me just copy this formula and paste it on the chat box so that everyone can follow over here. Okay, and so observe over here, basically, since this number, random number 0.149 is less than 0.5, that's why this is going to be an R. That's why we click to the right. And let me just press F9 again. So I generate out a new random number. Now it's going to be 0.856 over here. And 0.856 is bigger than 0.5. And so we're going to be kicking to the left over here. Okay, and so this is what we have. And so in a similar fashion, we're going to be doing the same for the goalie as well, whether if the goalie is going to be diving to the right or diving to the left. So let me just quickly run through it. Once again, if there are any questions, feel free to just type it into the chat box. So to generate out a random number, just put equals RAND and then open and close bracket. With this, I will generate out a random number in E3 over there. And so based on this second random number, we will decide whether if the goalie is going to dive to the right or dive to the left. Okay, and so the formula for this is if this number over here, which is in cell E3, is less than this number, which is in G1 over here, then we will say that the goalkeeper dives to the right. If not, we're going to say that the goalkeeper dives to the left. Okay, so let's do a quick check again. 0.01 is less than 0.5, and so the goalkeeper dives to the right. Okay, 0.59, it is bigger than 0.5, and so the goalkeeper dives to the left over there. Okay, the next thing that we want to do is that essentially we want to come up with the outcome over there. Okay, and so do we actually score a goal or not? And so to decide whether we score a goal or not, we have to essentially look at where the kicker has kicked and where the goalie has dived over there. Okay, and so once again, we're going to make use of our if statement. So we're going to use a equals to if. Let me just quickly just copy this one as well in case you need this. So this is essentially the formula for cell F3. Let me just paste it there as well, just in case you need that. Okay, let me come back once again to this outcome over here, which is we want to decide whether if there was a goal or not. And so for this, basically, we're going to use our if statement again. And we are asking if the value that is inside cell B3, is it the same as the value inside cell F3? So that's why it's if B3 is equals to F3 over there. If the two of them are the same, essentially what it means is that the goalie has dived in the correct direction. Okay, and so there's no goal over there. So then we put it, then that was going to be equals to 0. But if the two of them are different, that means the kicker has kicked in one direction and the goalie dives in the other direction, then we have scored and goal. And so then that's why the next parameter over here is essentially going to be a 1. Okay, and so we can do a quick check now. Since in this particular instance, we kick to the right, the goalie dives to the right, so there's no goal over there. Okay, so let me just press F9 again. Okay, so we generate out a new set of random numbers. In this case, we kick to the right, goalie dives to the left. And so under this situation, there is going to be a particular goal over there. Okay, and so you can do this many times to just go ahead to simulate this whole procedure over there. And so for us to do that, essentially, we don't want to just have it in one row. We want to have it in multiple rows over there. So here, I want to actually go ahead to simulate 10,000 kicks. And so if I want to simulate 10,000 kicks, basically, I want to populate 10,000 rows over there. Okay, and so I can just go ahead and copy this and then just go ahead and paste it down over there. Okay, so all you need to do is just go ahead and copy. And then you can just go ahead and paste it downwards. Okay, and so by doing so, you are going to be simulating, oh, let me see. My apologies over there. After I pasted it, I realized that we have a problem, right? If we want to copy and paste it, then you want to make sure that this cell doesn't move downwards over there. Okay, and so because previously I was referring to cell C1, if I copy and paste it down, it moves down to cell C2. I don't want that. This is correct. The reference over here is correct, but I don't want this reference to move down over there. So very quickly, my apologies. Let me amend the formula over here. So in front of the C1, in front of the 1 over here, I want to actually go ahead and put a $sign. Okay, and then same thing as well. In front of the G1 over here, I want to go ahead and put a $sign over there. Okay, and once I do this, then essentially what is going to happen is that then when I copy and paste it down, this cell is going to move down, this reference cell is going to move down, but this cell is not going to move down because I will continuously be referring to row 1 over there. So that is what that $sign actually does. Okay, and so very quickly, let me just amend this function over here. My apologies for that. And this one over here as well. Okay, and once we have that, and so we just need to copy and paste it down all the way. So let's say we want to simulate 10,000 kicks. An easy way, it's basically that we want to actually just go down to the row of 10,000 and 2 over there. Okay, and so you realize that we start from 3, right? So 3, 4. And so let's say if we go all the way to row A 10,002, so I access it via this cell over here. I can come to the end over here. And so what I can do is that I can actually go ahead and type in some values over here. So you can just go ahead and type in random values. The reason why I want to do this is because in Excel, if you were to just press the control button and you press a direction button, you are going to go to the next populated cell over there. So in this particular situation, if I press control and I press up, I'm going to move up to this cell which has something over here. Okay, and so if I come over here and I press control and I move down, I'm just going to come down to this last cell over there. And so making use of this, if you have already entered values in your row 10,002 over here, what is going to happen is that we can just come back up over here to the top. We can just go ahead and copy this row. And then I can hold on to Control Shift and down. It brings me down to row 30 for the first time. Let's just hold on to my Control Shift and I press down again. It's going to go down all the way to the row 10,002 over there. Okay, and then I can go ahead and press Enter. And basically, I would have copied all these values within here as well. Okay, and so let me just quickly demonstrate this again. So every time I teach Excel, this is usually the one that my students will need me to run through it again. Okay, and so the first step that we want to do is that we want to recognize that we want to simulate 10,000 kicks. So since I'm starting at row 3, basically if I want 10,000, that means I need to go to row 10,002. So let's go to cell A 10,002 over there, okay? And so over here at row 10,002, let me just type in some things. You can just type anything in. Okay, the important thing is just that the cell is going to be occupied. So once the cell is occupied, we can go control direction up to go back up to this cell over there. Just go ahead to select these cells. You can drag your mouse or you can basically just hold on to Shift and press right. Okay, Shift basically allows you to select the cells. Hold on to Control, press on to Shift to select and press down. The control down brings you down to that row 10,000 and holding on to Shift means that you're going to be selecting all these rows. Okay, and so with that, you are going to be able to copy and paste it over here. Okay, so hold on to Shift, press Ctrl C to copy, or you can essentially just go ahead and click this copy icon over here. Realize that we have these dotted lines already. With that, press Ctrl Shift and down. You will then be able to come up with, to populate out all these cells over here. Okay, and once you have that, then essentially the next thing to do over here is that we actually want to count how many of these are goals over there. Okay, and so for us to do that, this is going to be very simple. So this essentially is just going to be equals to the sum of all these cells over here. Okay, and so this is going to be J3 all the way to J 10,002. Okay, and so it's just going to be J3 to J 10,002 over there. Okay, and so from here we can see that out of this 50,000, out of these 10,000 cells, 5,096 of them are going to be goals. Okay, and so the misses are essentially just 10,000 minus away the number of goals up here. Okay, and so because it's random, every time you press F9, it's going to keep changing over there. Okay, but with this, essentially then from here, you are able to see that we will be able to have that if the kicker was to kick right 50% of the time and the goalie dives right 50% of the time, then on average, 50% of the kicks are going to end up in a goal and 50% of them are going to end up in misses over there. Okay, and so this is going to be very similar to the one that to the answer that everyone has given. Okay, so in a situation where if your kick or your dives are all left, this is where you want to come to. Let me just share this with everyone. So in a situation that if you have all left over there, then perhaps what it means over here is that this is not referring to this correct cell over there. Okay, and so recall that you need to put this dollar sign in front of the 1 over here. Okay, and so that is potentially one of the reasons why. The other reason over there is going to be if you were to go to your data and then let me see, sorry, your formula over there. You want to come to your calculation options. You want to make sure that your calculation options are automatic as well. Okay, if it's manual, then basically it will not automatically calculate it. So those are probably the two reasons if you do see that your values are all left or are all right. Okay, and so it should actually have a 50% probability of kicking left and a 50% probability of kicking right over there. Okay, so I hope that helped to solve that problem. So, all right, great. So, and so with this, basically, we have already answered our first question, right? So 50% of the time, we are going to score a goal. So that's well and good. So what about the second question that we have? We had a second question where essentially we're asking, what happens if the goalie dives right 40% of the time? And so for us to investigate this, essentially we can just go ahead and press 0.4 over here. And with this, basically what is going to happen, you can then go ahead to see what the result is going to be. Okay, I had a question regarding the summation. So let me just copy this and bring it over and share this with everyone. Yeah, my bad over there. I didn't share the formula for the formula over here. So basically, it's just going to be this, which is the sum of J3 to J100 and 10,002. Okay, and with that, let me just come back to this over here. And so basically, we can see that if the kicker kicks right 50% of the time and left 50%, and if the goalie was to dive right 40% of the time, perhaps surprisingly to many of us over here, or perhaps surprisingly, that actually the probability of scoring a goal is still going to be 50%. And so in fact, if you want to think about it, let's try 0.3. If you try 0.3, you realize that it's still a 50-50 chance of scoring a goal. Let's go to the extreme. Let's say if the goalie is always going to dive left. So I put the probability of diving right to be 0, so that the goalie is always going to dive left. What is going to happen over here? You realize that the chances of actually scoring a goal is going to be 50% as well. Okay, and this shouldn't be surprising, right? Because if the goalie always dives left, and if the kicker was to, kick left 50% of the time and kick right 50% of the time, then obviously 50% of the balls are going to end up to be a goal, and 50% of them are going to end up to be a miss. Okay, and so I hope one interesting fact you've gained from this is that regardless of the probability of the goalie diving left or 20%, 30%, the probability of a goal is still going to be equals to 50% over there. We have a question regarding what's the formula for the misses. It's basically just going to be 10,000 minus away the number of the goals over there. Okay, and so let me just put that up here as well for everybody. Okay, but this is where you're going to realize that if the kicker knows that the goalie is going to be diving right 20% of the time, what is going to happen? Then the kicker actually wants to kick. The kicker will actually wants to kick right more, right? Because if the goalie is less likely to dive to the right, then the kicker would essentially want to kick to the right more over there. Okay, and so if you see that if you were to kick to the right 70% of the time, then you're going to score more goals. Okay, but this is where the goalie is going to realize that, hey, I shouldn't be diving too much to the left so that it's going to be obvious to the kicker, right? And so the best for both parties over here in this particular scenario is essentially that the kicker will kick to the right and left 50% of the time, and the goalie would also do the same. And so there is going to be a 50-50 chance over there. Okay, and so with this simulation, I hope you are able to see how we are able to answer those first two questions over there. I do realize that I'm actually running a bit short of time. I think I've underestimated the amount of time that this is going to require. And so let me just go ahead and share with you the completed simulation over here as well, so that very quickly we are able to run through the one where the left kicks actually miss 50% of the time. So let me just go ahead and share that with you. So my apologies over here. I do realize that I probably have underestimated the amount of time we require for this. Okay, and so with this, very quickly, let me just talk about the next question that we have over here. I am mindful of time, so I hope that we would be able to end, I guess, latest by 6:10 or 6:15. So very quickly, let me just run through the formulas for this part 2 as well, okay, which is not going to be too different. So in part 2, basically, we are just going to add a further complication, which is that our left kicks actually is going to miss 50% of the time over there. So we're just going to need to have another consideration, which is that when the kicker actually kicks to the left, is it going to be on target or not? Okay, and so for us to do that, basically, we just need to generate out another random number over here. And so that's why I have another random number over here. And based on this random number, we will then be able to decide whether if the target is going to be, whether if the shot is going to be on target or not. Let me just quickly copy this formula to share with everybody. But of course, you can also see it on that completed spreadsheet as well. And so basically what we are saying over here is basically that I'm going to have a nested statement over here. And so basically what I'm saying is that if my B3 over here is going to be left, and if my P3 over here, and if this number is less than 0.5 over there, under this situation, I say that it's going to be a miss. So if I kick left, and if this number over here is less than 0.5, then I say that it's going to be a miss. But if I kick right, or if this number over here is bigger than 0.5, then I say that this target is going to, this ball is going to essentially be on target. And so with this, essentially what we're doing is that we're simulating the fact that left kicks are going to miss 50% of the time over there. Because when the kicker decides that it's want to kick left, we have an additional consideration that this random number must be bigger than or equals to 0.5 before we say that that ball is going to be on target. And so once we have this, essentially then we know that we are able to simulate on whether if that ball is actually on target over there. And once we have that, then we can decide the outcome. Okay, the outcome over here is essentially just going to be this outcome multiplied by whether if it is on target or not. So this outcome over here, recall basically just tells us whether if the kicker and the goalie have actually chosen the similar direction. If they have chosen the similar direction, then basically it will be a 0. That means it will be a miss because the goalkeeper would have saved the ball. If the direction were different, then it would have been a 1. And at the same time, if it is on target, so for the goal to actually occur, basically they have to choose the different direction and the ball would actually have to be on target. And so that's why this multiplied by this will then decide on whether if it was a goal or if it was a miss over there. Okay, and then once you have this row over here, essentially we just need to go ahead and copy and paste it downwards. And then over here, basically we just count the number of outcomes over here. And then here basically it's just 10,000 minus away the count of these outcomes over here. Okay, and so this is essentially the building of the simulation. I think I can leave it to you to work on it on your own free time over there. But what I do hope is that basically we are able to just quickly do the quick discussion regarding the results over there. Okay, which is that the third question that I asked everybody just now, which is that suppose if the kicker knows that the goalkeeper is going to dive right 40% of the time. Sorry, that was the wrong question. The third question I asked you was, suppose that the left shots over here only have 50% chance of being on target. How often should the kicker actually kick to the right over there? Okay, and if you were to look at our polling results says that we're saying that 70% of our, we should be kicking to the right 70% of our time. Okay, that seems to make sense because the right side is our strong side, right? And so essentially we want to kick to our strong side, let's say more frequently over there. And so let's put in 70% over there. And so you realize that if we kick to the right 70% of the time, and if the goalie dives to the right 50% of the time, then what is going to happen over here is that we are going to score goals about 42% of the time, and we're going to miss the goal about 48%, 58% of the time. Okay, somewhere around those range over there. So, but this is where you want to put yourself in the shoes of the goalie. If I know that the kicker is going to kick right 70% of the time, or in fact, even if I don't know that the kicker is going to kick right 70% of the time, if I know that the kicker is stronger on the right side and the kicker is going to kick to the right side more, what am I going to do? I should actually dive to the right a bit more, right? And so if the goalie dives to the right only 50% of the time, you realize that we have about goals 42% of the time. But the goalie is not going to do this, right? The goalie is going to dive right a bit more. Let's say the goalie dives right 60% of the time. This is where you realize that the goalie is going to save a lot more goals, and the probability of scoring a goal drops to 36%. But instead of 60%, the goalie might actually want to do 70%. You realize that the goalie is going to save even more goals. If we go to 90%, it's going to save even more goals. And if I just basically just keep diving right, then basically I'm going to save the most number of goals. And there's only a 15% chance that the kicker is going to end up scoring a goal over there. So what should the kicker do? So the kicker, recognizing that the goalie is going to dive to the right because the right is my stronger side, the ideal thing for the kicker to do is to kick to the left more, correct? And so basically I can just go ahead and say that I'm just going to keep kicking to the left over there. Okay, and if I just keep kicking to the left, essentially there's going to be a 50% chance I'm going to score a goal. Because 50% of the time I kick to the left, my ball is not going to be on target over there. Okay, but obviously in this case, if the goalie realizes this, then the goalie is just going to keep diving to the left as well. And the goalie is going to save all the goals over there. Okay, and so I hope you can see from here, then it's kind of a never ending, right? So it's a never ending game between the kicker and the goalie over there. So what should the kicker do over here? So this is where you realize we could try this strategy. So what if the kicker was to just kick right 50% of the time? Under this case, the goalie can decide to also dive right and left 50% of the time as well over there. But this is where you realize that can the goalie actually do even better? And the answer is yes over here. Simply because the kicker is actually poorer on the left side over there. Okay, and so if the kicker actually kicks to the left, there's already a 50% chance of the kicker missing it. So the goalie doesn't have to worry that much about the left over there. And so from that perspective, the goalie would want to increase the probability of going to the right. So the goalie would want to defend the right even more. So if I do it 80% of the time, I save more goals. In fact, if the kicker was to kick right 50% of the time, the ideal strategy for the goalie is to just keep diving right over there. The goalie should be protecting the stronger side of the kicker. Okay, but then obviously the goalie will not be able to do this, right? Because if the goalie do this all the time, then the kicker is going to kick left. Okay, but then let's say we can do a 0.9 or something like that. Okay, and so then the kicker would ask himself or herself, can I actually do better than this? So if the kicker was to basically just reduce kicking, was to kick right a bit more, then you realize that the number of goals are going to increase over there. Simply because in this case, what happens over here? So in this case, what happens here, rather than kicking to the right 50% of the time, if I just bring it down to 40% of the time, that means I kick left more over there. Under this situation, what is going to happen is that more of my left balls are going to go in because the goalie is solely focused on protecting the right over there. Okay, and so you can go ahead and try these strategies over here. You could see that if the kicker actually kicks to the right, it is still optimal for the goalie to keep defending the right over there. Okay, but what happens over here is that if my kicker was to kick to the right with only 30% chance, under this situation, if the goalie was to actually dive more to the left over there, the goalie would actually go ahead and save more goals over there. Okay, and so if the kicker only kicks to the right 30% of the time, you can play around with the numbers. You realize that diving to the left is going to actually end up with better results than diving to the right over there. Okay, and what you can do is that you can just play around with the numbers. And I'm going to show you a very special number over here, which is a 1/3. And so you realize that if the kicker was to kick to the right 1/3 of the time and kick to the left 2/3 of the time, what is going to happen over here is that we're going to end up in that same situation that we have previously, where regardless of what is the strategy of the goalie, the probability of a goal is always going to be 1/3, and the probability of missing is going to be 2/3 over there. So you can go ahead and try this out on the simulator over there. Okay, regardless of whether if the goalie decides to dive right or left 50% of the time, 60% of the time, it is not going to have an impact in terms of the percentage of goals over here. Okay, and so in game theory, this is what we call an optimal equilibrium over there, where essentially what happens is that because the kicker has chosen this strategy to kick to the right only 1/3 of the time, there is nothing that the goalie can do to actually increase his or her chances of actually saving or missing the goal over there. Okay, and so this is very similar to the previous case that we have, right? When the kicker's left and right leg were the same, then essentially the kicker's optimal strategy back then was to kick left and right with 50% of the chance. But in this particular situation where if the right kick is stronger, what is going to happen over here is that the goalie is going to recognize that because your right side is stronger, so you want to take advantage of that and kick to the right even more. And so the goalie would defend the right side even more. And for the kicker who recognizes that the goalie understands this, the kicker would then sort of like kick to the left more to take advantage of the fact that the goalie is protecting the right side more. And the goalie is actually happy with this simply because by protecting the right side more, the goalie has forced the kicker to kick on the weak side even more over there. Okay, and this actually ends up to be the optimal strategy for both the kicker and the goalie over there. Okay, and so you realize that if you were the kicker, basically if you were to just kick to the right 1/3% of the time, then essentially nothing that the goalie does is actually going to have an impact in terms of the final goals that you have over here. Okay, and so with this, I hope we have demonstrated to you sort of like how simulation could actually be used to evaluate the decisions that you make, or essentially some of these strategies that one might potentially want to employ over there. Okay, I do recognize that we have overshot in terms of the time over there. I do apologize for that. But if there are any questions, I'll be happy to answer them. So I think I've come to the end of the presentation over here. I hope that you were able to at least kind of get the grasp in terms of how to build the simulation. If not, don't worry. Like I say, I've already shared with you the Excel spreadsheet. We have a recording of this as well. We will make it available to you once it's going to be ready. I hope that at least we have tackled an interesting problem, and then to demonstrate the use of this simulation. We do have a quick question over here, so let me just run through this. My bad. Could you explain the wanted results in no change of goals again? Sure, I can do that. So very quickly, let's think about this in this way, right? So what happens over here is that if I was to kick right 50% of the time and kick left 50% of the time, what is going to happen is that every time I kick right, there's going to be that ball is always going to be on target. But if I kick left, there's only a 50% chance that ball is going to be on target over there. So recognizing this, the goalkeeper would actually want to defend the right side more over there. But if I was to just reduce this number over there, so once I drop from 50% to 40%, so what happens over here is that there is only going to be 40% of the shots. That means 40% of my shots are going to be on the right side, and those are all going to be on target. What about the remaining one? The 60% of the shots are going to be on the left side, and 30% of those shots are going to be, and half of those are going to be on target. So that means on the left side, I have 30% that are on target. On the right side, I have 40% on target. So what happens if I bring it to 1/3 over here? If I bring it to 1/3, then basically what happens is that 1/3 of my shots on the right side are going to be on target. And then I have 2/3 of my shots on the left side, right? And of those, only half of them are going to be on target. And so by using this strategy over there, I end up in a situation where 1/3 of the shots on the right side are on target and 1/3 on the shots on the left side are on target. And so under the situation, actually to the goalie, basically it doesn't make a difference anymore. So there isn't a preferred side for the goalie to actually defend. And so I can defend it 50% of the time right and left. That's not going to make a difference. Even if I change these numbers, it is also not going to make a difference as well. Okay, and so that is why once I have 1/3 of the time kicking right, then essentially nothing that the goalie would do is actually going to have any impact. Okay, so with that, I hope that explains it a bit better. We do have another question. Let me just bring it up over there. Okay, so is there a way for a simulation to factor in human bias? So there always is. Then that is where you need to be very clear about what type of bias you are going to be expressing over there. Okay, so I guess in the simplest sense is that let's say if a human doesn't decide something 50-50% of the time, but 60%, 40% of the time, then essentially this simulation that we have already illustrated to you will then be able to demonstrate this. There are a lot of other biases that people tend to demonstrate over there, which is that if somebody sees that, oh, there's too many rights already, then the next one over here, the humans have a tendency to switch to left over there. And so it is possible through simulation that you do a bit of programming to say that, okay, so if there's already a series of 2 or 3 rights over there, I'm going to increase the probability of left by how much over there. Okay, and so those are potential ways that you can try to factor in the human biasness in terms of your simulation over there. Okay, but for you to do that, then that is where you need to have a good understanding as to how this human bias begins in the first place. Okay, great. Thanks for those questions. And I think that the time is already 6:17. I do apologize for running so much over time. This was a gross underestimate of the time required on my end. My apologies over there, but my email is always available. And so let me just drop my email over here for everybody. If ever you are interested or if you have any other questions, feel free to just drop me an email. I will be happy to just take a look and give a quick response. Okay, and so like I say, the recording is going to be shared. So let my colleague just download it, do the necessary editing, and then once it's ready on YouTube, then we will share it with everybody. Okay, so thanks again for taking the time to join us for this workshop. And then I hope that it has been helpful to you. Any questions that you have, feel free to just drop me an email and I'll be happy to answer it.